In this course, we'll architect Notarized as a Cosmos-based registry chain. You'll see how Cosmos SDK and CosmWasm work together for SSI, land records, and digital notary use cases, and how IBC lets our registry interoperate securely across the wider Cosmos ecosystem. If you already understand Hyperledger Fabric, Cosmos will feel familiar, just inverted in a few key ways. The ordering service becomes CometBFT, a decentralized BFT consensus layer instead of a centralized orderer. Organizations and peers map to validator sets. Validators can be open and permissionless, or tightly governed like Fabric orgs, but with economic incentives baked in. Chain code is replaced by Cosmos SDK modules plus Rust smart contracts, separating core chain logic from extensible features. And instead of isolated permission networks, Cosmos chains are built to communicate natively through IBC, forming an internet of blockchains. Cosmos nodes are built in clean, separable layers, which makes them a strong fit for custom registries like your notary use case. At the top is the application layer, your Go state machine. This is where you encode business rules, how SSI identifiers are stored, how land records are updated, how fees work. Everything domain-specific. Underneath, CometBFT handles consensus, proposing, voting on, and finalizing blocks without any awareness of your business model. At the bottom, the networking layer runs the peer-to-peer fabric that gossips transactions and blocks across validators. CometBFT is the consensus layer that actually locks the registry in place. Validators run a Byzantine fault-tolerant proof-of-stake protocol in 3 phases. A block is proposed, validators pre-vote, then pre-commit. When enough pre-commits are collected, the block is finalized and cannot be reverted. That absolute finality is critical for legal records and verifiable credentials. A land title or notarized document can't live on a chain where blocks might be orphaned. Notice the separation of concerns. CometBFT orders transactions and delivers finality. Your Cosmos SDK modules implement the business rules. In Cosmos, everything your modules care about lives in the KV store. You can think of it as a deterministic key, value database wrapped in a Merkle tree. Every write updates the IAVL tree root, giving you a cryptographic fingerprint of all registry state that light clients and other chains can verify. To keep data manageable, you slice the KV store into logical segments using prefixes. Each module gets its own namespace and can define its own key structure, such as owner plus credential ID. Crucially, only the state machine may change storage, and only during deliver text. That strict timing is what makes replayed blocks produce identical, verifiable state. Almost all business logic in Cosmos lives inside Go modules that follow a predictable flow. A transaction carries one or more messages. For notarized, that might be a MESG notarized document describing what the user wants to do and proving their intent with a signature. Message servers or handlers receive those messages, run validation and domain rules, then delegate to the module's keeper. Keepers are the only code allowed to touch the KV store. They read and write state, enforce invariance, and give you a clean boundary between business logic and raw storage. On this chain, responsibilities are cleanly split between Go and Rust. Go, through the Cosmos SDK, gives you the durable backbone. Networking, consensus, and tokenomics stay stable and upgrade on slower, governance-driven cycles. Rust lives inside CosmWasm as an isolated smart contract layer. That's where you encode Notary and SSI verification rules that will inevitably change more often. Because those contracts run in a sandboxed VM, third parties can ship or update verification logic safely and deterministically, without risky core chain forks or redeploying the Go application. In a Cosmos app chain, ABCI++ lets your application shape blocks before consensus, instead of validating only after they're proposed. The proposer pulls transactions from the mempool and runs prepare proposal. Here you can filter spam, drop structurally invalid registry updates, and prioritize critical SSI or land record operations. Then every validator runs process proposal. They recheck the proposed block against your business rules and notary invariance before voting. This proactive application-aware flow keeps malicious or non-compliant transactions out early, improving security, block space efficiency, and overall throughput. On a notary blockchain, you never want every account to do everything, so you separate concerns into 3 roles. Admin defines the rules of the game, which schemas exist, who can notarize them, and which exceptional governance actions are allowed. Minters or notaries are the only ones allowed to mint credentials or notarize specific document types. Users simply submit documents and read verified records. Every transaction first runs a roll check, and only if the roll matches does the state change. That preserves strict access control and immutable registry guarantees. In this design, notarized isn't a sidechain hanging off another network. It's a sovereign Cosmos zone with its own validator set, token economics, and governance, but still able to interoperate securely. That interoperability comes from IBC. Each chain runs a light client of the other and exchanges cryptographic proofs over an IBC channel, with off-chain relayers just moving data, not providing trust. This lets external Cosmos chains verify identities, land records, or notarize documents on demand, without mirroring all the data or trusting a centralized bridge. In production, validator nodes are treated as critical security assets. They hold consensus keys, so they're isolated behind a sentry layer and never exposed directly to the public internet. Sentry nodes act as a shield. They peer with the validator and with public full nodes and relayers, absorbing traffic, DDoS attempts, and network churn. Public RPC and REST endpoints live on separate full nodes that are optimized for queries and API load, not consensus. To harden this setup, use strict firewalls, a minimal OS footprint, and preferably HSMs for validator key management. Bootstrapping a Cosmos chain is really about defining the very first trusted state. You start by initializing the chain, which creates the skeleton configuration and a draft Genesis file. Next, you generate and manage keys for validators and operators. These keys will control consensus and block production. Then you add Genesis accounts and allocate initial stake and roles, encoding all of that into genesis.json. Finally, validators create and exchange their Gentex transactions, assemble them into the final Genesis, and start their nodes so block height 1 can be produced. For a legal registry chain, you design for failure from day one. First, you need fast incident detection, then a way to freeze damage without killing the chain. An emergency pause does exactly that. It blocks new registry mutations while blocks continue, so liveness and consensus aren't disrupted. Next, on-chain governance gives you a controlled way to roll out upgrades or parameter changes on a precise timeline. Finally, state export and migration ensure you can move to new software or infrastructure without ever risking loss of notarized records. Keeping a Cosmos-based registry healthy depends on strong observability. You typically export node metrics into Prometheus and visualize them with Grafana, watching CPU, memory, block times, missed blocks, and peer counts. When something breaks, you dive into ABCI logs for check techs and deliver T-Rex to pinpoint failing contracts or invalid credentials, and you analyze consensus logs and timeouts to detect partitions, double signing risks, or misconfigured validators. Everything we've covered comes together into a single trust fabric. Go and the Cosmos SDK give you a sovereign chain with clear, modular state management. CometBFT adds instant, provable finality, so registry entries behave like signed legal instruments, not best effort messages. On top of that, Rust smart contracts via CosmWasm hold the verification logic, how identities, land records, or notarized documents are validated and updated. And finally, IBC lets this registry talk to the rest of the Cosmos ecosystem, turning notarized into a scalable, interoperable anchor of decentralized trust.